Good morning, everybody. So in today's lesson, I'm going to be showing you how to deal with and or probability problems. So one piece of advice I can give you as you're working through these questions is whenever you see the word or, think to yourself, am I double counting an outcome of an event? All right, can these events happen at the same time? And you'll see what I mean as we go through these four examples. So most of it is kind of common sense, but let's have a look anyway at the first example. So you got this class of students, and the following data summarizes how many students have a brother or a sister. So what is the probability that a student chosen from the class has a brother and a sister? So remember, whenever you're doing probability, it's always the number of successes over the total number of possible outcomes. So we're trying to find the probability that we've got a brother and a sister. All right, well, how many people do we have all together in the class? We've got 3 plus 2 there, so that's 5. 9 plus 16 there, that's 25. 25 plus 5 means everything has to be out of 30. So when I'm talking about having a brother and a sister, I need to look at these four boxes right here and see which one applies. So this one right here are all the people that have a brother and also have a sister. So therefore, the answer for this one would just be 3 out of 30. And that would reduce as a fraction to 1 out of 10. So remember, you can leave your probabilities as fractions. If you want to leave it as a decimal, that would be 0.1. And if you also want to leave it as a percentage, it would be 10%. So hopefully that one was a little straightforward. So let's look at one that deals with the word or. So there's a spinner with 15 equal areas. So that means each area has an equal likely chance of being picked. And when we spin it just one time, we want to figure out the probability that the result is going to be a multiple of 5 or a multiple of 3. So when we're looking at this, how many possible outcomes are there? Well, there are 15 different possible outcomes. So now we need to look at all the different ways of getting a multiple of 5 or a multiple of 3. So let's have a look at the multiple of 5 to start off with. So multiples of 5 would be 5, 10, and 15. Don't need to go higher than that because there's only 15 equal areas. And then for the multiple of 3, there's going to be 3, 6, 9, 12, and 15. So remember, if we're trying to figure out the probability of getting a multiple of 5 or 3, remember, it's all going to be out of 15. So the common mistake is that you would add up 3 plus 1, 2, 3, 4, 5, 3 plus 5 and get 8 and write that there. But the problem here is, and I said this at the beginning, whenever you're dealing with an OR problem, can something occur more than once? Getting a 15 in this case occurs more than once. So therefore, I don't want to double count it. So I've got 3 possibilities here, the 5, 10, and the 15. But for this one, I'm only going to count the 3, 6, 9, and 12 because I've already included the 15 in my count. So that's going to be 1, 2, 3, 4, 5, 6, 7 different possibilities. So therefore, my probability of getting a multiple of 5 or 3 is going to be 7 out of 15. So just be thinking as you're going through these problems, if it includes the word or, am I going to count my answers twice? All right, so putting a list down or making a table is often a good way of trying to eliminate that eventuality. All right, let's have a look at a couple more examples. Okay, so you have a certain algebra class, and there's 21 students in there. 6 of them play basketball, 10 of them play baseball, and the 7 students who play neither sport. And we want to figure out the probability that a student chosen randomly from the class plays basketball and baseball. So this is going to be an and question. Now, there's a lot of information going on right here, and it can be quite overwhelming to start off with. So in this particular case, I would recommend maybe putting together a table. So let's do that. So we're going to have the people that play basketball, and then we're going to have the people that don't play basketball. And then we're also going to have the people that play baseball, and then the people who don't play baseball. And I'm going to create table. This is called a two-way table of all my information. And I extended it here because on the bottom here, these are going to be our totals. So let's put in what we know. We know there's 21 students in the class. So that means my overall total, which will go right there, is 21. Now, 6 of them play basketball. So this is the row for all the basketball players. Now remember, some of them also play baseball and some of them don't play baseball. But I know the total number of basketball players is 6, so I'm going to write that there. Now, what else am I told? I'm told that 10 of them play baseball. So the same deal here. Here's the column for all the people that play baseball. I know the total is going to be 10. Now, I do have one other piece of information. I know that 7 students play neither sport. So that means there's no basketball and no baseball. So that would be this one here. So this is like an and. There's no baseball and there's no basketball. Now, I've got a lot of spaces that I didn't get any information for. So I need to make sure that I fill these in. But remember, all the totals have to add up. So 6 plus this total has to equal 21. So the missing number would be 15. Well, now that I've got this 15 right here, what plus 7 will add up to the grand total of 15? That would be 8. So now it's just a question of trying to fill in this table. It's kind of like a Sudoku puzzle. 10 plus what number has to equal 21? Well, that would be 11. What number plus 7 will give you 11? Well, that would be 4. And then what number plus 4 will give you 6, or what number plus 8 will give you 10? Either way you look at it, you're going to get 2. So now that I've got all of those values filled in, I can now figure out my probability. So we're trying to figure out the probability that someone plays basketball and plays baseball. Now remember, it's out of 21 students, and we're only picking that one student. So where are the people that play basketball and baseball? Well, these are all the people that play basketball. Here are all the people that play baseball. So this number right here is going to represent all those people that play both baseball and basketball. So my answer is going to be 2 out of 21. Don't need to reduce that fraction. I mean, we can't reduce it, so we leave it as a fraction. I would always leave your answer as a fraction. Sorry for the stutter there, because putting them as a decimal just requires more work. Obviously, if you do leave it as a fraction, though, make sure you always reduce it. All right, let's look at one last example. So in a class of students, the following data summarizes how many students play an instrument or a sport. What is the probability that a student chosen randomly from the class plays a sport nor an instrument? So we're going to go back to English class for this. So we're trying to find the probability that someone plays a sport nor an instrument. So that basically means they don't do any sports and they don't play any instruments. So these are all the people here that don't play a sport, and these are all the people here that don't play an instrument. Now notice the word nor, it's kind of like or. So therefore we have to include all of these people. So these are the people that do not play a sport. And we also have to include all of these people here. Those are the people that don't play an instrument. Now the problem is we've got 2 people that fall into that category twice, that either don't play a sport and don't play an instrument. So we want to remember not to include them twice. So what I mean is you don't want to be doing 13 plus 2 plus 3 plus 2, because then you've included these 2 people more times than you need to. So let's go ahead. How many is this out of? Well, 9 plus 13. That will give you no, not the other way. 9 plus 3 is 12. 12 plus 15 right there. That should give you a total of 27. All right, so I know everything's going to be out of 27. There's 27 students in total. All right, so now how many of them do not play an instrument and do not play a sport? Well, it will be the 13 right here, plus the 2 right there, plus the 3 right there. And remember, we're not going to count that one twice. So 13 plus 2 plus 3, well, that will give you 5 plus 13. That will give you 18, all over 27. Again, leave it as a fraction if you can, but 18 divided by 27, you've got to reduce that. 9 goes into that twice. 9 goes into that 3 times. And by the way, it's totally okay to write it as a decimal or a probability, or as a percentage. All of those three ways are totally acceptable. I mean, really, it's whatever you feel most comfortable with. Me, the less work, the better. Notice I didn't use any calculator. Maybe I should have. All right, anyone. All right, everybody. Have a great day. And if you have any questions, please don't reach out to me. Make sure you reach out to Miss Lynch or Miss Wiltsey. No, I'm just kidding. You can reach out to me if you want, but it'll cost you $5 a question. All right. Have a great day, everybody, and take care and stay safe.